So in this lecture, I want to talk about just the question of, when we look up in the sky, what do we see, what's up there, and what requires explanation? Because we want to establish sort of the early history of astronomy from a standpoint of where or when do we start trying to answer the question of what's really going on up in the sky? So what sorts of objects and cycles do we observe? And in a separate video, I'll talk about what sorts of astronomical knowledge were pre-scientific cultures, meaning cultures that didn't have telescopes and cultures that didn't have a mathematical science the way we do today. What were they capable of, and what kind of things did they know about the sky? So first of all, just plain and simple, what is up there in the sky? Stars. We go out at night, we look up in the sky, and we see a bunch of stars. Some are bright, some are dim, some are reddish, some are bluish. And they're always kind of the same. They make patterns in the sky that we call constellations, and those constellations change from year to year, but the shapes that the stars make in the sky are always the same. There's the sun. The sun rises and sets every day, although not always in the same place, and it doesn't always stay in the sky for the same amount of time, right? In the summer, it's in the sky for a long time and goes way up high in the sky. In the winter, it's in the sky for less time and stays down low in the sky. The moon is up there in the sky. The moon changes its appearance over the course of a month, from a full moon to a half moon to a crescent, and then back up again. And 5 things that look like bright stars but are different, because they move around and are not always in the same place every night relative to the other stars. We have named them Mercury, Venus, Mars, Jupiter, and Saturn. You might ask, where's Earth? Well, we didn't think of Earth as a planet until we realized that Earth also goes around the sun like these other planets. Where Uranus and Neptune, those you can't see without a telescope. So ancient civilizations did not know about Uranus and Neptune. They only know about these 5, what we would today call planets, or wandering stars. The name planet comes from a Greek word that essentially means wanderer. The planets are stars that are not always in the same place relative to each other the way the fixed stars are. Each of these, let me go back one second, each of these objects, the sun, the moon, and the planets, have cycles associated with them. The sun, for example, rises and sets, and we call the amount of time from sunrise to the next sunrise one day. The moon goes through its phases from full to gibbous to half to crescent, and then to invisible, and then crescent, and then back to full again. We call that cycle, or the amount of time that that cycle takes, roughly a month. The planets each have their own cycles where they repeat what they do in the sky. Mercury every 80 some days, Venus every 200 some days, Mars every 2.5 years, Jupiter every 10 to 12 years, Saturn every 30 some years. So days and years and months are all time periods that come from looking at stuff in the sky. There's another time period, though, that we use, at least in our culture, built around the number 7, and that's the week, right? There's 7 days in a week. The fact that there are 7 days in a week is not based on an astronomical cycle. There's nothing happening in the sky that takes 7 days to happen. But there are 7 interesting things in the sky: sun and moon, Sunday, moon day, and 5 planets: Mercury, Venus, Mars, Jupiter, and Saturn, Saturday. And the names of the days of the week are named after these 7 interesting objects. It's not easy to tell in English that that's true of all of them, because a lot of our words in English come from kind of Germanic languages, like Norse. For example, Thursday in English is, the root of that is Thor's day, like the guy with the hammer, Thor. And some of our names come from Norse Germanic languages. Wednesday, or Wednesday, is actually Woden's day, or Odin's day, as named after Odin, Thor's dad. But if you know the days of the week in some other language with closer ties to Latin, like Spanish or French or Italian, or if you know Latin, you can hear the roots of the days of the week and the names of the planets. For example, Monday is moon day, but it's lunes in Spanish, right? Like lunar. Tuesday is martes in Spanish, or mardi in French, named after Mars. Then you have mercredi, which is named after Mercury, or vendredi, which is named after Venus, or viernes in Spanish. So you can hear that the names of the days of the week are reflected in the names of the planets, or vice versa. So that's where the number 7 comes from. And 7 has a mythological importance in a lot of cultures. It's considered a perfect number or a heavenly number. 666 is the number of the beast because it's one short of 7, which is a heavenly number, and so on. What else goes on up in the sky that we need to pay attention to? There are extremely rare events like solar eclipses. Sometimes the moon goes in front of the sun and it blocks it out, and that's worth paying attention to because it's rare and unusual. Sometimes the Earth gets in between the sun and the moon and it blots the moon out. That's called a lunar eclipse, when the moon passes through the Earth's shadow. Solar eclipses and lunar eclipses are both fairly rare if you're stuck at one place on the Earth. Solar eclipses, if you can move around the globe on airplanes and boats and stuff, you can see one every 18 months to 2 years. But if you're an ancient civilization that was stuck at one place on the Earth, you would only see a total solar eclipse once a decade, once every 30 years, once every 50 years. The cycle is actually very, very complicated. A lunar eclipse is a little less rare. Again, one happens every 18 months or so somewhere on the Earth. But if you stay in one place, every couple of years you'll see a lunar eclipse. They're not that rare. There are very quick events that happen in the sky, like a meteor. A meteor is a little flash of light that zips across the sky. They've been known about for thousands of years. We've had names for them like shooting stars or falling stars. They're not stars. They are little specks of dust or ice or rock burning up in the Earth's atmosphere. Not to be confused with a comet, which doesn't zip across the sky very quickly. A comet shows up in the sky over the period of many, many weeks, gets brighter and brighter and brighter day by day, grows a long tail, maybe for a month or so, and then gets dimmer and dimmer and dimmer and fades away again, and seemingly never comes back. The fact that comets seem to show up out of nowhere and never come back was a big deal for cultures that paid attention to the sky, because things in the sky are cyclical. Days, months, years repeat themselves. The motion of Venus and Mars and Jupiter repeats itself. But comets seem to come out of nowhere and then go away again. And that was considered alarming. A lot of cultures considered comets to be bad omens or portents of doom of some sort, because something is happening in the sky which is supposed to be regular that was unexplained and unexpected. The most famous comet probably is Halley's Comet. Halley's Comet is not the most famous comet because it's the biggest, brightest, bestest comet ever. It is the most famous comet because it is the first one that somebody noticed, Edmund Halley, that, hey, if you look back into the historical record, every 70-some years, there was a comet that people saw. Maybe that's the same comet coming back every 70 whatever years, and it'll come back again on a particular time. And it did. And that's why we named Halley's Comet after Edmund Halley. I saw Halley's Comet back in the late 1980s, 1986 or so. It wasn't a very great appearance. It never got too far from the sun. It was never very bright. You needed a telescope to really see it. You guys will probably get a chance to see Halley's Comet again in the 2050s. I'd have to look up the date. I don't know exactly when Halley's Comet comes back again. I might see it. I think last time I checked, I'll be 88, 86 when Halley's Comet comes back. So I better start eating better if I want to make it to see Halley's Comet for a second time. But again, I don't think it's expected to be particularly bright or well placed next time, but it is a once in a lifetime for most people, at most a twice in a lifetime thing to see. So what do we see these objects in the sky do? The sun rises and sets every day, but the position in the sky of the sun changes. In the summer, it rises a little more northerly, and it spends more time in the sky, and it travels a path closer to the zenith. It goes closer to the point directly above your head. So the sun's rays are beating down on us directly in the summer and making the ground warm. In the winter, the sun moves on a lower path across the sky. It never gets very high above the horizon. It's up in the sky for less time. Its sun's rays are hitting the ground at an angle, and they warm the ground less effectively, so it is colder. Halfway in between, at the equinox, in the fall and in the spring, the sun is up for exactly 12 hours and down for exactly 12 hours. And this cycle of summer solstice to fall equinox to winter solstice to spring equinox and back again. This figure 8 pattern in this diagram is a photograph of the sun taken, or the position of the sun, taken every couple of weeks for an entire year. So over the course of the year, the sun is sometimes higher, sometimes lower, and this cycle from solstice to solstice is a year. The moon changes its appearance from invisible to crescent to half to full to half to crescent to invisible again, and that cycle takes about 29 and a half days, give or take. It's not exactly a half. That means there's a little more than 12 lunar months in a year. Our Western Christian calendar has months that are all different lengths, right? February has 28, and some have 30 and some have 31. That's got nothing to do with the moon. That's just the way we chopped up a year into groupings called a month. A real lunar month, the cycle from one full moon to the next full moon, is 29 and a half days, and that doesn't exactly line up to the number of days in a year, which is 365. Some cultures use calendars based on the seasons, like our Western calendar. Some cultures use a lunar calendar based on moon phases. If you use a solar calendar and you have a holiday that's on a certain date on your solar calendar, that holiday will always be in the same season, right? Christmas is always in the winter because our calendar repeats itself with the seasons. If you use a lunar calendar, for example, some Islamic cultures use a lunar calendar, and you have a holiday that's at a certain time in that lunar calendar, like, say, Ramadan. Ramadan is not always in the summer and it's not always in the winter because the lunar calendar is not in sync with the seasons the way the solar calendar is. So that holiday can happen at different times of what we would consider a year because our year is based on the sun, not on the moon. The stars are fixed in some sense, which is that stars always maintain the same position relative to one another. Okay? Meaning that if I have a constellation like this is the constellation of Orion, Orion always looks like Orion. You can't always see it everywhere on the Earth. You can't always see it at all year long. But the stars of Orion, the 3 stars that make up Orion's belt, and then the upper shoulder of Orion is the star Betelgeuse, and the lower foot of Orion is the star Rigel. Those stars are always in the same place relative to one another. And as Orion moves across the sky over the course of a night or over the course of the year, Orion always looks like Orion. That's what we mean by the fixed stars. But different stars are visible different times of the year because our position relative to the sun changes. So which stars are up at night changes over the course of a year. And if you go to different places on the Earth, you can see different stars. I think this is the Southern Cross, which I have never seen because I've never really spent a whole lot of time south of the equator, and that's where you have to go to see the Southern Cross. Likewise, someone who's lived all of their life in Australia has never seen the Big Dipper because you can only see the Big Dipper from our half of the Earth. Constellations aren't real. Constellations aren't groupings of stars in the real world. They're just stars that happen to be lined up from our point of view. They are made up groupings of stars by people drawing dotted lines between stars that look close together in our sky and giving them names and making up stories about them. For example, there's a story from ancient Greek Greece, that the constellation of Scorpio, the Scorpion, and the constellation of Orion, the Hunter, are exactly opposite one another in the sky. You can never see Scorpio and Orion at the same time. And the explanation for that was that the Scorpion actually killed Orion, and when Zeus put them up in the sky, he made sure he put them as far apart as possible so that they wouldn't bother each other anymore as they moved around in the sky. So constellations are made-up groupings of stars that we have invented and made up little stories about. They don't have any real astronomical meaning, but because they're a convenient way to talk about regions of the sky, astronomers still use constellation names to talk about where stars are in the sky and where other things are in the sky. Over the course of a night, one roughly 12-hour night, if you go outside and look at the stars, you will notice that they move. That if you look at the stars at one time of the night and come back an hour later, they will be in a different place than they were before. This is a time-lapse photo where a camera is just pointed north and the shutter is left open for, it looks like, about 3 hours or so. And during those 3 hours, you can see that the stars have moved and made streaks across the sky, except for one star, which stayed in exactly the same place. That is Polaris, the North Star. Note, Polaris is not particularly bright. It is not particularly interesting as a star. Polaris does not know that it is our North Star. Polaris is just a star that happens to be directly above the North Pole of the Earth. If you went to the Earth's North Pole and you look straight up, you would see that there is a star there. So as the Earth spins around in its circle, that star doesn't move. As the Earth spins around in its axis, I should have a globe in here so I can spin it around. As the Earth spins around in its axis, if you stood at the North Pole and looked up, you would see that that star Polaris was always directly above your head. Anywhere else you go on the Earth, as the Earth spins around, Polaris stays in the same place. That's the only thing special about it. There is no South Star. If you go to the southern hemisphere, there is a place in the sky that doesn't move, but there's not a bright star there. There's a constellation called the Southern Cross that goes around in a little circle, but there doesn't happen to be a star directly above the South Pole of the Earth the way there's a star directly above the North Pole of the Earth. By the way, the pole star, Polaris, the North Star, is only temporarily the North Star. That's because one of the motions of the Earth goes around the sun in an orbit. It spins on its axis once a day, but as it spins, it also wobbles like a top, meaning its axis isn't always pointed in the same direction in space. That wobble takes 26,000 years. I don't remember the number. It takes more than 20,000 years to go around once, which means Polaris is a North Star now, but as the Earth wobbles on its axis, some other star will be the pole star in 10,000 years. And for sometimes there won't be a pole star at all because that axis doesn't happen to be pointing at a particular star in space. So the pole star is an accident, and it's temporary, and it's just a coincidence that right now, at this point in human history, there happens to be a star directly above the North Pole. Here's a similar time-lapse photo taken with a camera pointed east, and what you see is over the course of a night, the stars rise in the east, they go around the pole star, and if we pointed this camera west, we would see them setting in the west. So over the course of the night, just like the sun rises and sets over the course of the day, the stars and planets and moon rise and set over the course of a night. Another thing we see in the sky is this diffuse stripe of light. It doesn't look this detailed and pretty with the naked eye. With the naked eye, it just looks like kind of a band of diffuse white light that goes from one horizon to another, called the Milky Way. The Milky Way is a diffuse band of light that crosses the entire sky. It's a little bit brighter in the direction of Sagittarius. There are some places where it's darker because things are blocking our view of the stars. And it is our galaxy and all the stars in our galaxy. You can think of taking a picture of the Milky Way as, imagine you went to a concert and you tried to take a picture of the crowd, right? If you tried to take a picture of the crowd in the concert, because all their heads are at the same level as you, all you would get is a stripe of heads that go all the way around you. The Milky Way is just a stripe of stars that goes all the way around us in space because we are embedded in the center of this group of stars, this flat group of stars called the Milky Way galaxy. Planets move in a way that is very complicated. I told you that the Greek root for the word planet means wanderer. Whereas the stars in a constellation are in the same place relative to one another over the course of the night. If you look at a planet like Mars and look at it one night, and then the next night, and then the next night, and then the next night, the position of Mars relative to the background stars will change nightly and sometimes even go back in the other direction for a while. That's called retrograde motion, and then continue in the original direction, changing every single night, not always moving the same distance, not always moving the same speed. And this cycle of the motion of Mars or Jupiter or Saturn or Venus is quite complicated and repeats itself over many, many years. Understanding the motions of the planets and why they move the way they do is a big contributor to our eventual discovery of science and the scientific method, which we'll talk about in a separate video. So these are the things that we know are up there and what they do without a telescope. There's a sun and moon and planets and stars, but why do they move the way they do in the sky? Why is the sun sometimes high and sometimes low? Why does the moon change how much of it is lit over the course of a month? Why does Mars sometimes change direction and go the other way for a few weeks? What causes the very slight variations in position of the sun and the moon that cause the seasons and planets? Why is the moon higher at the solstice and lower at the equinox and even lower at the winter solstice? And what are these things anyway, these lights in the sky? What is the moon versus the sun? Are they the same kind of thing or are they different kind of things? What are the planets? Are they the same as stars or are they different from stars? These kinds of questions are going to take us from a purely descriptive notion of what the things in the sky do to an explanatory notion of why the things in the sky do the things they do, which will take us from a pre-scientific view of the universe to an actual honest-to-good scientific view of the solar system and the universe. So what we'll talk about in another lecture is, what did ancient cultures know about these motions? And what, if any, descriptions or explanations did pre-scientific cultures make or try to make of the things that happen in the sky? So that's what we'll talk about next.